Good morning, good afternoon, and good evening to everybody who's dialed in here. Thank you all for joining today's webinar titled How to Manage Hortonworks HDB Resources with YARN. My name is Yves Laurent, and I'm the Director of Alliances and Partner Marketing here at Hortonworks. I would like to thank you for taking the time out of your schedule to attend this session. This webcast is the third one in a five-part series. In this webcast, we will demonstrate the integration of Hortonworks HDB and Apache Hadoop YARN, and we will also cover the installation process as well as discuss the various YARN and HDB parameters and best practices settings. The other sessions in this five-part tech webinar series are how to get started with Apache Madlib on HDB, and that will be on November 2nd. And on November 16th, we'll have another webinar, which will be the final one, on how to use Apache Zeppelin with HDB. Let me now introduce Dan Basquet. He's the Director of Technical Marketing for Data and Analytics at Pivotal. Dan has over 20 years experience in various pre-sales and engineering roles, and is the leading expert on HDB, which is powered by Apache Hawk. A link to a recorded version of this session will be also available on the Hortonworks website under the section Events and Webcasts, as well as on the Pivotal microsite, which will be under hortonworks.com/partner/pivotal. With that being said, let me hand it over to Dan.
All right, thanks, Steve. Today we're going to talk about Hawk, Apache Hawk, or Hortonworks HDB and its integration with YARN. Quite a broad topic, so we'll cover it at a reasonable technical level and show a demo of how we get it set up and use it, and then answer some questions at the end. All right. So as the agenda, like I said, we'll cover some basics of YARN itself, just to give a quick refresher, and then show the integration, and then the live demo. All right, so why do we care about YARN, and what are some of the basics about it? All right, so YARN is really an important piece of the Hadoop stack, right? It allows us to really have multi-tenancy in the environment. Right, so one piece of the stack doesn't overwhelm everything else. So not only from different components, but from different users as well. So very important for multi-tenancy. With that, also resource utilization. So if I have service level agreements and things like that for particular applications leveraging Hadoop, right, YARN really allows me to control the amount of resources of particular applications so that I can meet those service level agreements. It's going to enhance the scalability by really throttling some of the resources dynamically or statically throttling those based on how I set up the system. But it's going to allow me to scale out different applications at different levels within the Hadoop architecture. So it's really a slides. It's a cluster. Why does it keep changing? Cluster resource management tool. So YARN not only does the global resource allocation across the cluster, but also manages those local resource assignments as well. Right. So it's going to do all the resource allocations, assignments, and report on those at a central location to allow you control. So it's going to allow me to manage things like CPUs, memory, and then network and disk I/O are definitely on the roadmap. Right, so just briefly talk about some of the components. Right, so the major YARN component would be the resource manager. So that's going to run on a management host and really control the global resource management. So it looks at things from the cluster level and manages how I distribute workload across the cluster. Inside a particular node, we run the node managers, and those are going to manage that all the local resource allocations. So they're going to basically allocate resources to allow you to run particular applications on any particular node. The application master, there's one of these per application, and it really manages the life cycle of that application. So when I spin up an application to run leveraging YARN, I get an application manager, and it's going to schedule the tasks into containers in the system. And then those containers are basically just a resource abstract, right? So some number of CPUs and some amount of memory that I have reserved to run a particular application. It's not like I wouldn't think of it like a Docker container or something like that. It's really just almost like a reservation on CPU and memory for a particular application. All right, so within that, I also have the ability to do things like run different types of schedulers to handle that resource allocation. So in this case, we're talking about capacity scheduler, since that's what Apache Hawk will support. And these schedulers really allow you to create these hierarchical queues so that I can manage resources in groups across the YARN cluster. So if I have particular user groups within my enterprise, say in engineering and marketing or research and development, I can give them access to a particular subset of the resources within the Hadoop cluster and manage that at a very granular level. All right, so let's talk about the resource management and integration with YARN for Apache Hawk. So resource management in Hawk is really a three-tier resource management framework. So at the highest level, it can be globally managed by YARN. So since YARN is at a cluster management level, this is going to really control the amount of resources that are given to Hawk as an application itself. Right, so that's great for managing multi-tenancy across different applications, but we also would like to manage multi-tenancy within an application itself. So the next level of that resource management is a Hawk resource queue. So these are resource queues that are defined within the database itself to allow the same type of functionality resource queues would at the YARN level, but within groups of users in the database. So I can define those same marketing, R&D, engineering groups inside the database and allocate resources that YARN's given to me to those groups at a level. So an example there would be at the YARN level, I might carve my cluster up and give Hawk 50% of the resources in the cluster. Within that 50%, I can then use the Hawk resource queues and divide it up even more and say, all right, this marketing group is getting 25% of that 50% and so on. And then the third tier is really internal and not user managed at all, but it's really query optimization and prioritization of commands within the database itself that allow sort of a resource management within the Hawk engine itself. So it's seeing what resources available to it, and then we'll optimize the query based on those resources. So that's not something you manage, but the query optimizer is going to manage a lot of that. All right, so if we look at the high-level architecture, so the blue box there in the middle is really the Hawk engine itself. So it talks to YARN via its resource broker and libyarn. And then, so that's going to be the way it negotiates its resources. All right, then that runs alongside things like the optimizer, or parser, and analyzer, and a catalog cache for the name nodes, so that when I'm allocating resources, I know which nodes to allocate those on. Right, so once I broker those resources, then I can start to farm those out and hand them out to the segment servers and the virtual segments within the data nodes themselves to provide resources for queries. All right, so if we look at the concepts, sort of broke these into small granularity and large granularity. So if I start on the right, the large granularity, these are things that I don't want to do very often. So typically they're much more high latency. So allocating of containers within YARN is what I would consider a high latency operation, right? So I don't want to do that for every piece of a query that gets allocated to Hawk, because then I'm going to suffer the time associated with allocating those containers for every query. Right, so these containers are typically pre-allocated, and they'll have we'll have a minimum number of these things pre-allocated and can allocate more on the fly. But they'll have timeouts, so they'll live for some period of time, and then I can restart them as needed. So those containers become sort of your working environment for Hawk itself. If we move more to the small granularity, right, these are typically things that are going to happen quite frequently and need a much lower latency. So in this case, this is things like allocating virtual segments to process parts of a query, or running these query executioner processes. So what happens is these containers basically give you a space to work. So if I assume all the containers on the right are one processor, 1 gig of memory, when I drop that fourth one on there, I now have 4 procs, 4 gig of memory. And then within Hawk itself, I can spin up virtual segments to consume that and run these query executors to run the query itself inside that framework of container, CPU, and memory. So it's in this way we can get very low latency, very good response times for the queries themselves, and we don't have to go to YARN as often to allocate these containers. Right, so in the case if we want to look at the flow of how things happen, YARN, the resource manager within Hawk, will talk to YARN, get some number of containers, and then as a query comes in, right, the queries will get parsed, and then the optimizer will help build the plan. So now we have a tree-based plan of what I need to do to go execute that query, and I need to send that to the dispatcher so that it can dispatch the pieces of the query to different nodes for execution. That's going to spin up these virtual segments within that container space that we've taken from YARN when I started up Hawk. Right, so now I have containers. I can dispatch my query to run inside that space that's reserved with those containers, and I can execute that query on the nodes themselves. And that would be the slice data in the QEs, or the query executors. Right, so Apache Hawk in YARN mode. Apache Hawk basically registers itself as a YARN application, and that resource broker will run as an unmanaged application manager, meaning it doesn't run inside of a YARN container itself. It's independent and runs independently of YARN. And then we'll basically send heartbeats back to YARN just to say that, hey, we're still registered and we still need these containers so that we can keep those containers. So it's a lot like Hive LLAP, the way that application and some others work, and how it's going to reserve these containers for longer periods of time. The QEs then run on the segments with Node Manager running. If Node Manager drops, then Hawk won't be able to tell there are containers available on that, and it'll take that node out of the Hawk cluster. It won't be used to try to allocate processing. Right, and then within So within those container spaces, Hawk actually enforces the resource utilization in all the segments. So it knows it has a certain container space to work in. So if it had that 4 CPUs, 4 gig of memory on each host to work within, it'll actually manage to stay underneath that itself. And that's what allows us to then carve it up even more with Hawk resource queues. All right, so if I want to configure Hawk to work with YARN, it's a couple different settings, and we'll go through these in Embari in the demo, but just so that you sort of know what to look for. Capacity scheduler is required, and basically you'll create a queue that gets allocated out to Hawk within Capacity Scheduler, so we'll show that as well. A couple properties here that when you install Hawk, most of these are preset, but then you can change them if you need to. So Hawk Global RM type, so this is the Global Resource Manager, and to enable YARN control with Hawk, you basically just change that to YARN. And the default setting is standalone, meaning that Hawk will statically define its cluster size and run basically its own containers based on the segment memory settings. So it doesn't need YARN to run, but it can leverage YARN if you would like. The YARN address is basically just the YARN Resource Manager. Then we'll have a setting for the YARN Scheduler address. Then you'll tell Hawk the queue name that you want to use within Capacity Scheduler. And then the Hawk RM YARN app name is the application master name that you'll see within the Resource Manager web UI. Inside Hadoop, it's Hadoop YARN itself. So really, those are really the only settings I need to get YARN up and going. I can play around with some of the YARN container sizes and things like that. That doesn't really have huge effects for us since we're just using that as a working space anyway. So 4 containers is no different than one big container for us. We'll execute within that framework the same. So changing container sizes doesn't really matter to us one way or the other. That's settings really better left for the other applications within the Hadoop cluster. And we call this friendly Apache Hawk YARN resource return. So Hawk's not going to reserve a bunch of all the resources it needs to run queries at all times and never give those back. So it'll go out and allocate the minimum number it needs at first, and then really go out and allocate more containers and things after it gets the query plans if it needs more. So we'll have a minimum number, and then we can ramp that up. But any containers that are allocated can then be, I believe the default's 5 minutes. We'll push those back to YARN as non-used containers, and that space gets freed up. So, but that size or window size of 5 minutes is actually configurable, so you can do it however you would like. Right, so the Apache Hawk Resource Manager really tries its best to get evenly allocated containers across all the nodes. So it will definitely try to get the same number of containers across all the nodes so that it has basically equal processing across the cluster. It is an MPP system, Hawk is, so it really, the speed of any query depends on the slowest node. So we really depend on all the nodes performing at pretty close to the same speed to get an optimal performing cluster. So it will go out and try to get the same number of containers across all the nodes. Right. So if I have 10 nodes and I need 20 containers, it's not going to do 4 on some of them and 2. It'll do 2 per across. All right. So then when it decides to return containers, it'll do the same. So it'll return them as the same number per host if it can, or if one happened to have more containers than the rest, then it will return off that one first, just to try to keep this even resource consumption consistent across the whole cluster. Right, and so one thing about Apache Hawk, so we get the data locality for the cluster via queries of the name node, right? So that's one new feature in Hawk versus some of the prior releases, where we'll go out on a per block basis to determine the data locality. So in this case, when Hawk Resource Manager starts to allocate the VSEGs to do processing, it's going to allocate those VSEGs on hosts that have access to that particular block of data. So I build my query plan, I need to access a particular row in a particular table. It'll get the block information for that, and then the VSEG to actually go and read that will then be started up on the node that has access to that block. So that could be multiple nodes based on HDFS replication, but we do try to maintain data locality that way. Hawk has basically what we'd call a name node cache, so that when it goes out to retrieve block information for the tables, it'll cache those inside Hawk so that it doesn't have to go back to the name node for the subsequent lookups. But we do maintain data locality via that name node query. All right, so that sort of explains the YARN pieces, and now we have that next level I talked about, which is the Apache Hawk resource queues. So these are all implemented via standard SQL DDL statements. So really create resource queue, alter resource queue, or drop resource queue. And I pass these in things like a core limit for the queue or a memory limit for the queue. And then I assign users to those queues so that they're controlled, but their resource consumption is controlled by that queue itself. So like Capacity Scheduler, these resource queues are also tree-based. So we have a PG root, which is really all the resources of the cluster. And then underneath that, I have a default queue. So that's really everyone that's undefined will go into the default queue. And then everyone that is defined gets their resources defined in their queue. So we'll show an example of this in the demo itself. But it looks a lot like the Capacity Scheduler model, and it really is sort of the same in that respect. All right, so let's take a look at the demo. All right, so I've got a Hawk cluster and running YARN. It's a multi-node cluster. And in this case, I've got, we'll look through these settings. So here it's set for standalone. I can change that to YARN. I also have the ability to go into advanced, and I can take a look at some of the other settings we talked about. So I can set the YARN address. Here's my YARN application master name, my YARN queue name, and my scheduler address. So all these settings are in the standard config section for Hawk. So what I want to do is basically run a query. We'll run some queries with Hawk in standalone mode and sort of take a look at what it looks like when that's happening. And then we'll turn YARN on and then take a look at what it looks like then, and then allocate some internal Hawk resource queues to make it sort of that third comparison. So if I look at my container status, so since Hawk's in standalone mode, it's basically has some memory settings for CPU or it has container settings for CPU and memory that it knows it has. So in this case, it says, all right, I have a 1 CPU, 4 gig container on these hosts, and there's some number of those on these hosts. I think 16 total. So I have 16 cores, 64 gig of memory to allocate. All right, so in this case, Hawk thinks it has access to the full cluster, and it would try to use the full cluster. All right, so this is one reason you might want to use resource queues to control it from using the whole thing if I'm not using YARN. But if I go and we'll start up some queries. All right, so lots of queries inside of Hawk, and if I look at status here, I see all the queries running. I don't have any resource queues, so those are all going to start up and try to run. And if I look inside of Embari, and as these things update, we'll start to see the performance go up, right? So the CPU utilization and things like that. All right, so in this case, no YARN, no resource groups. This is just flat out everybody running. So I have multiple users executing multiple queries. So obviously that's not the best way to go. So we can kill those queries and we'll see those things start to die, and then we'll go allocate. Once we get that back down to nothing, all right, now we can go in and we can start up YARN. So go into configs, change the resource management to YARN, save, then I'm going to go restart Hawk. So if we look, since it was in standalone mode, here I have my capacity scheduler queues, and really nothing was being used because that one wasn't actually turned on. Once we get Hawk restarted, all right. Now I look at the applications running within YARN itself, and I have the Hawk application master running, right? Like we define that name. It's using my Hawk queue, and basically has 0 containers allocated to run. If I look at my capacity scheduler queue, I see nothing's running, but see, hey, it's configured at 25% capacity of my capacity on both memory and CPU. One of the nice features of Embari is this YARN queue manager. Oops. Get that going. Doesn't want to run my queue, that screen. All right. Well, when that's running, you can go and change the, has basically a GUI to change the allocations of the capacity scheduler queue itself. All right, but now I have Hawk running, and it's in the YARN mode. So if I check my container status again, all right, so now I see, or before I saw all these containers, right, resource containers, basically using up all the memory and CPU of the system. Now I have really nothing there. So it tells me what's available based on my resource groups within capacity scheduler, but that's it. So now we'll start up some queries. And go back, and we'll start to see, now we see containers spinning up to run. So now I have 9 containers running across this 3 data nodes, so 3 containers per, and the queries are going to go run. And now if I look at my Hawk queue, I should see So now some portion of that queue is being used. And I see the query performance is now running. Give this one more try. Like that still. All right. All right, so now if I go and look at my container status, now I see these containers and what they have allocated. So 1 core, 3 gig of memory, and running those queries. I can also look at just the status. I still see those queries running. We don't have anything defined within Hawk itself, so it's not going to limit it at all. All right, so now if I want to kill off those queries, let's see it work its way down. All right, queries are now gone. Now I can go, and if I look at my, let's just take a look at this one script here. All right, so in this case, I'm going to create some resource queues, basically give 90% of my Hawk resources, which is 25% of my cluster. Now I'm going to further subdivide that and say, all right, the default queue gets 90, and then these other users get 5% each. All right, so if I run that, and now I see, all right, PG default, which is that default queue, gets 90% of memory and core. User 1 gets 5. User 2 gets 5 as well. So now I can start to run these queries. One more. And we see that where I was doing multiple containers before, where I basically had 3 containers of 3 gig each, so 9 gig allocated to run these per host. Now I'm limiting that down to a max of 2560 per user per inside in memory. So it's definitely going to limit the performance of the queries. If I come back in here, and now you see, because of those limits I set, I didn't need to start up as many containers. So I'm only starting 6 containers to run the processing for those queries. And then if I look inside my queues, now I'm further down on that that queue of what it could actually use. So it's just visually looks at around 50%. So that's 50% of 25 is 12.5, and I limited these things to 10. So it's pretty close to that number. All right, so it's running these as it runs these queries. All right, so I can kill those off. And then I have an author resource queue. So in this case, now I want to make default 20 and the other one's 40. Let it finish killing these queries. And you don't have to kill queries to make these changes. I'm just doing it so that I can better visualize what's happening as I make these changes. All right, so if I alter the resource queue, actually I need to change the name. Oh, there we go. So So we want to basically change the resource queue of user 1 to 40%, and user 2 to 40%. Extra S. All right, so now we make that change, and now as I go and start these queries, lots of queries per user. All right, now that end-use memory has grown because it definitely has more resources to access. And now my Hawk queue is definitely utilized more than before, and I've started more containers to actually process that data. So now I have 10 containers. Or in the beginning I had 9, then we dropped it to 6, and now we're at 10 running those queries. All right, so that's really the demo. So we can look at questions within the chat. Let's see. So are all the containers pre-allocated based on cluster sharing, or new containers created as queries come in? All right, so we answered in this beginning, and then hopefully the demo showed you that, all right, some of those queries, or some of those containers will be pre-allocated, a minimum number on the first set of queries that come in, but then we'll free those up, and then I can allocate new containers sort of on demand behind that. So some will be pre-allocated, and we'll keep those around in case the new queries come in, so that I don't always have to recreate new containers. So the answer is sort of both there. So they can be created as when they come in, and yes, they are pre-allocated. So that's the only question I'm seeing in the box. Anyone else have questions? I'll give it a couple minutes. Right. So now those queries have started to finish off, so we're actually passing some of those containers back. All right, can Hawk recognize Hadoop users as their planned integration with Ranger? So yes, I mean, on the Ranger side. So there is planned integration with Ranger. I don't have the JIRA in front of me at the moment, but if you look on the Apache Hawk site, you should be able to find the JIRA associated with Ranger functionality being added. So that's coming. I won't say in the next release, but hopefully soon after. So I would say sort of early next year at the latest, I would hope. And can Hawk recognize Hadoop users? Really, Hawk's going to manage the permissions and resource allocations within itself, so that it has its own database users. So those database users are typically not the same as the Hadoop users. They can't have the same names, but just because you have a Unix account as user 1, that doesn't necessarily mean you have a user account within Hawk as user 1. So you would have to be created in there separately, and then we control the permissions and resource group allocations within Hawk using that particular user. Right. Right. Do we have any other questions? Trying to get my capacity scheduler GUI to come back up. Will Hawk have a YARN application master container which will monitor container spawned? It does not have. It has a application master container, it has an application master process, but it is not a YARN container. So YARN knows about it. So in this case, this application that gets spun up, YARN knows about it and communicates with it, but it does not run inside a YARN container per se. Right? But so I named that. Here it's named Hawk, and if I looked in the Hawk configs, I had the ability to name that application master or whatever I want. So I define it within the Hawk site. All right, that's bizarre. All right, let's say 2 more minutes for more questions. Yeah, so sort of back to the Ranger question. That's actually one of the, what I would say is the top requests that I've heard from people, is just that unified way to handle some of the user permission sets, really across all applications in the Hadoop ecosystem. So Hawk is definitely wants to play nice within all that Hadoop ecosystem, and it's really why the YARN integration was added, the Embari integration was added, and then we'll just continue down that path. Is the Hawk application master on YARN a single point of failure? No, we have within that we have basically the ability for it to get respawned, right? Because YARN knows about it. So it can definitely be respawned, and it's not technically managing anything from a query perspective. It's just allocating. It just manages the container, sort of the container allocation from YARN out to Hawk itself. So once Hawk knows about the containers it has, then it can continue to run, and we can respawn. So no, it's not a single point of failure. What are the typical use cases for Hawk on YARN? I wouldn't say there's typical uses for Hawk on YARN any more than just Hawk itself. So Hawk itself is an MPP analytical database leveraged for business intelligence, high-end analytic queries, and machine learning, leveraging the Apache MadLib machine learning libraries. There'll be a follow-on seminar in a couple weeks to talk about the MadLib integration with Hawk that you can tune into to see some of that. But really, it's a high-end analytical database running. So what YARN allows me to do is, so the first demo example I showed was really where Hawk started, which was when it runs as a separate application from the rest of the ecosystem and doesn't manage its resources in the same way. Really what you have to do is do this sort of static resource allocation. So I would go in and tell Hawk that it had could only start up a certain number of containers, and maybe that's, say, 50% of every node. All right, so then I would need to go make sure that within YARN that it wasn't going to allocate much more than 50%, and so that the two didn't step on each other. All right, so what YARN added was the ability for the other Hadoop applications and Hawk to know about each other, so that I can better utilize all those resources and I don't have to make static allocations. in that case, does Hawk utilize the full potential of YARN resource management? Yes, in that it's, right, so YARN is that global resource manager. So it's managing multiple applications, and you basically tell YARN how much of the potential processing that I want to let Hawk use at any given time, right? And those things can go, when there's nothing else working on the system, right, they can go above those numbers typically, but it's a way to subdivide all those resources. And then within that, Hawk can then carve it up even more. So I would think it uses the full potential of YARN as much as anything else, right? And even more so in that I can further allocate it sort of that next level down. If a customer wants to use SQL on Hadoop with integration with visualization tools, is Hawk a good use case? Yes, because Hawk has its history with the Greenplum database and Postgres, so it looks and feels like a Postgres instance to really integrate all the visualization tools. So it works with all those. It has full ANSI SQL support. If I look at things like TPCDS, it can run all the queries unmodified. So any of the SQL that the visualization tools or BI tools generate, it's going to handle a lot better just because of its history as a sort of a non-Hadoop database engine. So it started as a database and then moved to Hadoop. And can Hawk work on a Kerberized cluster? Yes. So when you install Hawk with Embari, it'll recognize it's been Kerberized, and I can make all those settings. My demo cluster is not, so you didn't see those settings. But if you have a Kerberized cluster, all the settings for service principals and things like that will all appear, and you can configure it for Kerberos within Embari itself, so it works just fine. All right, any last questions? All right, well, what I'll say is if anyone has any other questions, my slide at the very end disappeared that had my email address, but feel free to contact me at dbaskette@pivotal.io, and I can answer follow-on questions if you'd like. That's dbaskette@pivotal.io. And with that, thank you for joining, and have a great day.